Morning, students. In continuation to the earlier video lecture series, we have been seeing the modes of heat transfer. In this, we have seen the convection heat transfer, and in the earlier video, we have classified what is the two different types of convection. What is the natural convection and free convection here. For natural convection, the heat transfer takes place purely by the density difference. This is caused by the temperature difference here. Whereas in the forced convection, the external agency is required for the heat transfer to take place between the surface and the fluid here. A fan or blower is required for the heat transfer to happen here. So the law which governs the convection heat transfer is the Newton's law of cooling, which is given by Q convection is equal to HA delta T here. As you can see in this equation, the heat transfer is proportional to the surface area and to the delta T, that is the surface temperature with respect to the ambient temperature or fluid, not ambient temperature, fluid temperature. So where H is called as the convection heat transfer curve, which is expressed unit for H is watt per meter square degree Celsius. A is the surface area, Ts is the surface temperature, and T infinity is the temperature of the fluid, uh, which is having contact with the hot surface. The convection heat transfer H is not a property of the fluid; it is an experimentally or empirically determined parameter which depends upon the following variables here. So the following variable it depends upon the surface geometry or nature of fluid motion, the properties of the thermal properties of the fluid, and the fluid velocity, bulk fluid velocity here. So the H is not a single dependent parameter. It depends upon various parameters, which makes the determination of H as a very complex one here. So for some of the values which you normally use for the H for the free and forced convection, the example is given for free convection of gases is close to uh, 2 to 25 watt per meter square degree Celsius. For free convection of liquids, 10 to 1000. For forced convection and with respect to gases, it is close to 25 to 250, whereas the forced convection for liquids it is 50 to 20,000 here. So this is a typical value of H which will lie in the range for the free convection of gases, free and forced convection of gases and liquids here. Coming to the next mode of heat transfer is the radiation heat transfer. So in comparison to the conduction and convection, it doesn't require a medium, whereas the convection and the conduction requires a medium for the heat transfer to happen here. So radiation mode of heat transfer is completely different from the other two modes of heat transfer. Radiation is the energy emitted by the matter in the form of electromagnetic waves or photons as a result of changes in the electronic configurations of the atoms or molecules here. So thermal radiation is the energy emitted by the matter that is at non-zero temperature here. So this radiation heat transfer does not require the presence of participating medium or intervening medium here. So the maximum rate of radiation heat transfer that can be emitted from a surface at an absolute temperature Ts is given by the famous equation known as the Stephen-Boltzmann law, where Q maximum emitted from a surface is equal to sigma t power 4 here, sigma a t power 4. So where sigma stands for the Stephen Boltzmann constant, which is equivalent to 5.67 into 10 power minus 8 watt per meter square Kelvin power 4, and A is the surface area and T is the surface temperature of the surface. So for a real surface, the maximum rate of radiation is found out by the following equation, which is given by sigma a delta t power 4 multiplied by epsilon, which is nothing but the emissivity of a surface here. So emissivity of a surface is defined as the emissive power of a real surface to the emissive power of a black surface here. So these are the following references which we have referred for the this three modes of heat transfer: conduction, convection, and radiation. So in continuation of the forthcoming video lecture series, we will try to focus on the uh, fundamental heat conduction equation. Thank you.